Okay, if you have your textbooks, we are starting at in chapter 1, and we'll cover chapter 1 and the first half of chapter 2. This very first week, it's really easy stuff. Okay, the material definitely gets harder by the time we get to chapters 3 and 4 and things like that. Okay, but in the beginning, it's all nice and easy. Keep up to date, stay on top of your homework and things like that. Yes?
Do you recommend we bring our books to class?
I think so, but if it's too much of a hassle, you don't have to, okay? But I think it's good. All right, so we are learning statistics. All right, so why do we study statistics? Yeah.
For like research and probability.
Okay, research and probability. All right, I guess that's true. Statistics will help us in that, but the same could be said. Well, not the probability part, but studying history and things like that, right? So, yes.
Finding trends or patterns.
Yes, finding patterns. Okay. Yeah. Okay. So, why do we study statistics? So, well, I'm going to say the reason why we study anything is to learn about the world around us. Okay. Okay. Well, that's why we study anything in general, and specifically statistics allows us to make conclusions. Based on limited data. So data is information. Okay? We live in a world where information is being collected at all times on all sorts of things. Okay? Just your being here, you are generating data. Probably through the use of your cell phone, okay? Probably some, depending on who you've given permission, and possibly even people you haven't given permission may be tracking your location based on the GPS signal of your cell phone, and they have an idea. They have an idea of what websites you go visit and who you're in contact with and things like that, okay? We are all generating data. But as much data as there is out there, we usually don't have access to all the data, okay? So we are dealing with limited data, okay? So even if we wanted to answer some question, okay? So let's say we want to answer what is the average income of what is the average household income in the U.S., okay? Well, what does it mean to get an average? If I want to ask what's the average of these 10 numbers, what would you say? How would you calculate the average? Yeah.
You add them all together and then divided by the number of...
Yeah, okay, so that's finding the mean. We'll talk about this in a moment here, but you've probably learned this, right? If you have 10 numbers and you want the average, you add the 10 numbers up and you divide by 10. And this gives you the average of the 10 numbers. Okay? So if I asked you what is the average household income in the United States, how can we get the true answer to this? The true answer. The true answer, what does this require? It requires knowing exactly how many households exist in the US, and knowing the income of every single household in the US, okay? Requires us to know the income of every household in the US. Okay. And which also requires us to know the number of households in the US, okay? Okay, and then to get the average, what do? We add them up. And then divide by how many households we have. And that would give us the true average household income at that moment in time. Okay. But this is practically impossible, okay? Because we can't get a hold of every single household in the US, okay? How do you define a household? Okay, that's a very difficult question. So you need very specific ideas of how you define a household, and then you'd have to go out and collect all this data on how much income everybody makes, okay? Now the IRS might have an idea based on what people report and things like that, but it's still not every single household, right? Because not everybody reports all of their income to the IRS. And so the answer is complicated, okay? So there's no way for us to get all of this information, but we still want to know an idea of what the average income in the United States is. We still need this kind of information for people to make policies, right? Where should we set poverty line? Right? Who qualifies for these benefits? Who doesn't? You know, at what point do you move up into the next income tax bracket? Things like this. People make laws, and they make them based on the information that they have. Okay, and so we have limited data, and we use statistics to allow us to make these kinds of conclusions. Okay, so we cannot collect all of the data required. Okay, so we can't collect all of the data required from the population. Instead, we have to deal with a limited amount, and we call that a sample. So maybe instead of trying to gather information on all the households that exist in the United States, however million households there are, maybe we just collect a sample. Maybe we identify 5,000 households, and we interview them and we ask, what is your annual income? And then based on that 5,000 households, we can get an idea of approximately what the average income in the United States is. Okay. So that's one of the reasons why we study statistics, is so we can make conclusions based on limited data. So here's the idea. We've got a population, which is some some large entity that we cannot gather information for everyone, okay? This is usually lots and lots, okay? This is large. Generally, we can't get everybody in the population, okay? Or can't collect information on everyone in the population. Maybe we can, okay? If you're a company and you have a list of all of your employees, that could serve as your population. You have a list of everyone, okay? But rather than trying to study everyone from the population, you select a sample of data. This is small, and we study the sample. And we hope that whatever we learn from the sample can be generalized to the population. And in order for us to be able to generalize back to the population, our sample needs to be representative of the population.
Bless you.
So if our sample is not representative of the population, for instance, if our sample is just millionaires, then whatever conclusion we make is going to be wrong, okay? If we interviewed 5,000 millionaires and we asked how much money do you make, everyone says, well, I make this $1 million. And then we would come to the incorrect conclusion that the average income in the United States is some $1 million, okay? Your sample needs to be representative of the population, and we will talk about getting a representative sample, okay? At this point, it'll just serve us well to say, one way to get a representative sample is the random sample. One way to get a representative sample is the random sample. And random has a specific meaning in statistics. We'll talk about that. Okay. Random is different from arbitrary. So a lot of times when we think of data, we think of numbers, okay? But it's not just numbers, okay? So data often consists of numbers. numbers to be meaningful, they have to have a context. Okay? Meaning, there's a place where we got these numbers. Okay? We're not just making up the numbers, unless we are making up numbers, but generally, whenever you have data, the numbers were collected somehow. Okay, we could go around the classroom and I could ask you, how tall are you? And I would get numbers like 64 inches and 72 inches and 68 inches or something. Okay, we would get a bunch of different numbers based on people's heights. Okay, but those numbers represent people. Okay, so the numbers have a context. And the reason why we have this subject of statistics, so we can draw conclusions from limited data, okay? The biggest reason is that everyone in the world is different, okay? And that we call that variation. Variation exists. Okay? Everyone is different. Variation exists. Everyone is different. But the amount of variation is some things have lots of variation, other things don't have as much variation. Okay? So, for example, when you go to a when you buy clothes, okay? If you want to get a suit or a jacket or something, they're going to have different size jackets, and that's because people are of different size, right? There's people with large bodies, people with small bodies, things like that, okay? And if they sell a one-size-fits-all jacket or one-size-fits-most jacket, it probably doesn't look like it fits you very, very well, okay? On the other hand, you can buy safety goggles, and it's generally a one-size-fits-all, okay? And that's because the variation in people's head size and basically the size of their eyes and the spacing of it doesn't vary that much. Yeah, some people have larger heads than others, and some people's eyes are a little bit wider apart or different than other people, but the actual amount of variation is probably no more than a few inches, okay? Whereas when we're talking about a jacket or a belt or things like that, there's a lot more variation. So it's a lot more difficult to manufacture a one-size-fits-all belt or a one-size-fits-all jacket than it is to manufacture one-size-fits-all glasses, okay? One-size-fits-all safety glasses especially, okay? So everyone is different, but the amount of variation can be large or small, depending on the situation. Okay. So, body size, fairly large, variation. Okay. Or how about the size of of your contact lens? Okay, if you wear contacts, they have different prescriptions. But have you ever seen large contact lenses or small contact lenses? No, everybody gets the exact same size contact lens. Why? Because in terms of people's eyeballs and the size of that, there's not a whole lot of variation, okay? There is variation. Not everybody's eyeballs are a little bit different. If we were to, I don't know, if you were to die and pull your eyeball out and we were to compare its sizes, okay, people will have different sized eyeballs. But in terms of the size required for a contact lens, one size will pretty much fit everybody, okay? Okay, body size, large variation, okay. Eyeball size, not a whole lot of variation. Much less variation. And so we will learn about measuring variation very, very shortly. Okay. This week or next week. Okay. Okay. We've got two types of variables. Okay. When we gather data, we say the things that are different from person to person, we call those variables. Person to person, or item to item, whatever it is that you're comparing, okay? Things that vary are called variables. Okay, so, for example, if we went through our class roster, okay, and you know, here I got Jalal and Karen and Laura and et cetera, et cetera, et cetera. Okay, we've got different students. We could go around, and I will not do this, okay, but we could gather data on each of these students. We could say, what is your age? Okay, and maybe I'm making up numbers here, okay, so this is not, so maybe Jalal is 21 and Karen maybe is 23 and Laura, who knows, I don't know, 20 or something like that, okay? I'm just making up numbers. And so you know, people are different, people might have the same age, okay? So we could gather age, okay? We could ask your sex, whether you are male or female. So we have male, female, okay? We could say, you know, weight, okay? And we'll, you know, I don't want to even approach that subject here, okay? But you know, we could other things, right? You know, height and
Eye color.
yeah, hair color, eye color, et cetera, okay? So there's all sorts of stuff, okay? I have no idea, okay? I'm making things up. I should have just called these people different things, right? Like Adam and Bob and Carol or something, okay? So anyway, let's say you know, I'm again making up numbers. Who knows, all right? And maybe we have, maybe everybody has pronouns. Okay. Etc. Okay. So these things vary from person to person, okay? It just happens to be that these three people happen to have brown hair, or brown eyes, okay? So these things vary, and they are called variables, okay? We have two kinds of variables, okay? Or we're gonna classify variables into two types, okay? We have numeric variables, and we have categorical variables. Okay. Numeric variables are sometimes called quantitative variables. Okay. And categorical are sometimes called qualitative. But whatever, numeric and categorical, it's probably easier, okay? Numeric variables tell you, well, a quantity. How much or how many? How much how many years has so-and-so been alive? How tall is so-and-so, okay? These are numeric variables. So age and height, these are numeric. Categorical variables, on the other hand, they put people in a category. Okay? They tell you what type or what kind. A category. Okay? So sex would be a category. Eye color, category. Alright, so let's, so if we were to put weight on there, what kind of variable would that be?
Numeric.
Numeric, right? It tells you how much, measured in pounds or kilos, somebody weighs, okay? If we put, I don't know, shoe size. Yeah, shoe size would be numeric. You could make the argument that it's categorical, but I would say it's numeric, okay? Because you can compare. What if we put zip code? Zip code would be categorical, okay? Zip code does not tell you a quantity. It doesn't tell you how much or how many, okay? If you want to think, does this make sense as a numeric or categorical variable, okay? Just ask yourself, does it make sense to compare and say things like there is more, something has more or less, okay? So does it make sense to say someone has more years of life or whatever? Yeah, yes. You could say somebody is older, okay? Or more height? Yeah, you could say somebody is taller, okay? More shoe size in terms of, yeah, larger feet? That makes sense, okay? Does it, okay, if somebody lives in zip code 90029 and 90050, okay, does it make sense to say this person has more zip code than this person? No, okay, it doesn't, that doesn't make sense, okay? Because zip codes are just a label. They're actually, they tell you what type or what category you are based on just your physical location. Okay, so zip code would be categorical. Okay, there's going to be there's stuff in your book that I'm not going to fully cover in class, okay? Some of it you're going to have to read and do the homework problems, okay? Pretty much anything I put in the homework is fair game. Anything that we cover in lecture is fair game for a test, okay? There's something on stacked and unstacked data, and basically it's just how data is gathered, okay? And I think the book does a good enough job of explaining the concept that that I don't need to cover it here in class, okay? But if you have questions, again, feel free to post your questions on the Facebook group, or if you don't have Facebook, just send me an email, okay? So that's gonna, I'm gonna leave that to you in your reading, so read on stacked and unstacked, okay? Okay, but it's not that important, okay? All right, when we're looking at categorical data, okay, we can organize categorical data with what we call a frequency table. Frequency table, okay? And we can expand the frequency table into a relative frequency table. imagine we have the list of all the students here, okay? So let's say I have 80 students, okay? And we have, each student's name. And let's say we get hair color. Okay, and then so this is, Adam has, let's say, brown hair, and Betty has black hair, etc., etc., etc. Okay. So here I only put 2 students, but just imagine a list of 80. Okay. A frequency table will then summarize this. Okay, so we put this into a frequency table. And what this does is we have hair color, and so maybe we look at blonde hair. We'll say light brown. Maybe I probably need to distinguish between light brown, dark brown. Okay, black hair, and maybe red hair, and maybe gray hair. Okay. So anyway, let's just say these were all the things, and we call this a frequency table. Because maybe we have 10 students with blonde hair and 20 students with light brown and 18 students with dark brown hair and maybe 5 students with red hair. And if we have a total of 80, then everything has to add up to 80. So this would be 30, 48, 53, so 27. Okay. And so there we have, this would be a frequency table, okay? Total of 80 students. Is that okay? Simple enough. We can go from here to here. No problem. Okay. A relative frequency just takes the frequency column and turns them into percentages. Okay. Okay, so if I want to turn this into a percentage, what would I do?
Divided by 100.
No. How many students total do I have? 80. I would do 10 divided by 80, and I would get 12.5%. Okay, and 20 divided by 80 would give me 25%. And 18 divided by 80 is, I don't know, a little bit more complicated. 22.5%, 23.75%, I don't know, okay. Something, I don't know. Somebody's got to do the calculations there. Okay. Huh? Well anyway, you guys get the idea, right? 18 divided by 80, I don't, is that 23.75? Okay. So that's a relative frequency table. Is that okay?
22.5.
22.5. Thank you. And so on and so forth. So that's a frequency table. Maybe we were looking at 2 categorical variables at the same time. Okay? Then we can create a frequency table. We would call this a 2-way frequency table. This is if we're looking at categorical variables, we can organize with a 2-way table. table, sometimes called a contingency table. Alright, so again, just imagine here we have maybe, we'll just look at 6 students or something, okay? So I got student A, B, C, D, E, and F, okay? And maybe we ask, are you male or female? And then we ask, do you prefer Coke or Pepsi? Okay, so maybe Adam is male and he prefers Coke, and Betty is female and she prefers Coke, and C is female but prefers Pepsi, and female and likes Pepsi, and male and likes Coke, and male likes Coke. Okay, so let's say this is what we have. Okay, so now we can create a frequency table, okay? So I've got male and female. Okay, but this is called a two-way table because over here I'm going to put the number who like Coke versus Pepsi, okay? And this is just based on a sample of 6 people, okay? How many males total do I have? 3, okay? So I'm going to put the total at the end over here. Okay, and how many females do I have? 3 females. Okay, how many people like Coke total in my survey? 4, and Pepsi? 2. Okay, so these are all totals. Okay, so how many males like Coke? 3 males like Coke. And how many males like Pepsi? 0. Okay. And how many females like Coke? 1 and 2. Okay. So this is a two-way table. Alright, is this okay? Alright, and I could ask you a question. Okay. I could say, so there's a total of 6 people, right? So I could say, what percentage surveyed like Coke? Coke over Pepsi. And your answer would be?
4.
Yeah, what percentage? So the answer is 4 out of 6, which translates to 0.667. Or 66.7%. Are there questions on this? Yes?
Yeah, just referring to the initial data, you say that there's a two-way table and the relative frequency table and the frequency table.
No.
What do we call the initial data? This data?
Yeah, this is just a data table, okay? Oops. This is a two-way table, okay? Frequency and relative frequency table, this is, that's only for one categorical variable at a time. When you got 2 categorical variables, you got a two-way table, also called a contingency table. Yes?
What is that in the parentheses?
Contingency table? Contingency. Alright, so what percentage, and it's basically how many, contingent on the category, how many like Coke or something. Okay, so what percentage surveyed like Coke? The answer is 66.7. Okay, what if I asked what percentage of females like Coke? Females surveyed like Coke. What's What's your answer?
33%.
The answer is, how many females total do I have?
3.
3, okay? And 1 out of the 3 females like Coke. So the answer there is 33%. Like 33% of females surveyed like Coke. Are you confused, or is that
Shouldn't
okay?
it be 1 out of 4? instead of-
No, 1 out of 4 is a different question. Okay, I'll get to that. All right. So we've got, what percentage of females surveyed like Coke? How many females surveyed were there? There were 3 females surveyed. Of those, how many liked Coke? 1. Okay. A similar sounding question is, what percentage of surveyors who like Coke, or of those surveyed, what percentage is surveyed who like Coke, who like Coke are female? Okay, what percentage of those surveyed who like Coke are female? The answer is 1 out of 4, okay? Of those surveyed, 4 people liked Coke, and of those 4 people who liked Coke, 1 of them was female. So the answer here is 1 out of 4, 25%. Okay, of those who like Coke are female. Okay, is this okay? All right, and we can distinguish between these types of questions. Okay. Good. Okay, you got, you will have questions in your homework, and a lot of it is, back to arithmetic, dealing with percentages and proportions. Alright, what else do we have? So we've already talked a little bit about some of this. So this is kind of an aside, is that sometimes when we, to gather data, so this goes with section 1.4, okay? Gathering data in an experiment. Okay. We can gather data either through an observational study or through an experiment, okay? And gathering data in an experiment, I should say, or an observational study. Okay, let's talk a few of the differences, okay? In an observational study, we just observe, okay? We observe to gather data. We try not to interfere. We do our best not to interfere. On the other hand, in an experiment, okay, usually conducted because we want to know if changing one aspect has an effect on some outcome. Okay? We want to know if changing something has an effect on something else. That's usually why we conduct an experiment. So we want to know, does taking this medication have an effect on, I don't know, the health of someone? Does, you know, changing the environment here have an outcome, have an effect on, you know, some outcome, the productivity of the workplace, or something like that. Okay, so these are conducted to see if changing something has an effect on something else. Okay? The thing that you are changing, that is known as the treatment variable. Okay? So you want to know if changing the treatment variable has an effect on something else, and that is called the outcome or the response variable. Okay, so let's say alright, so let's say you see some commercial on late, an infomercial late at night, right? And they say they sell what? Some electrode thing you put on your stomach and you plug it in and it says it'll give you stronger abs. You guys know what I'm talking about? You've seen this? Okay. So you want to know, does this thing work, right? Alright, so you want to do an experiment. Okay, so let's say you go and you buy it and you put it up, you hook it up to your body, and you use this every day, and you don't feel stronger. Do you say, does that mean this product is crap?
No.
Okay, well the answer is, we don't know. It didn't work for you, okay? But that doesn't mean it will not work for anyone else, okay? Maybe it'll work for other people, maybe it doesn't, okay? But the answer is, the results of one person doesn't work for everyone, okay? Even the infomercial, they've got the testimonials, right? And they might be paid testimonials or they might be actual legitimate stories. But the truth is just the outcome of one people or even 3 or 10 people, okay, cannot speak for everyone, okay? We would actually have to do a real experiment, and we want to know if this product works, okay? Okay, so here's the other part, okay? If we didn't do an experiment and we just said, oh, okay, you know, let's find people who bought this product and let's survey them, okay? Let's just say we found 20 people who bought the product and we found 20 people who didn't buy the product, and we just want to ask, are your abs stronger, okay? So maybe you found people, and who knows, maybe the 20 people who bought the product, at the end of their, you surveyed them at the beginning, when you identified them or whatever, okay. You found 20 people who bought the product, and you found 20 people who didn't buy the product, and then you measure, you know, whose abs are stronger. Maybe it turns out that the people who bought the product, their abs are stronger. Does it mean, overall, on average, that the 20 people who bought the product, does it mean that the product works?
No.
No? What if we found 200 people? And overall, on average, the 200 people who bought the product, their abs are stronger than the 200 people who didn't buy the product. Does it mean that the product works? No? We got a whole bunch of skeptics here. Okay, why are you skeptical of this product working, even though the 200 people who bought the product seem to have stronger
They
apps?
might get their stronger apps from the gym or other places.
Oh, okay, that's great. Yeah, because
They might be people that are more focused on their like physical appearance, so their apps are already like that.
yeah.
And then the other, like, you can't measure it.
It's difficult to measure with just a survey, okay? Even with 200 people, maybe even more people, okay? The thing is, if somebody spent, you know, made 4 easy payments of $99.95 or whatever it is to get this magical ab product, they're probably interested or invested in getting stronger abs, okay? And maybe they sit around and they use this electrode thing. Maybe they also work out at the gym. Maybe they do a bunch of things to get stronger abdominal muscles. Who knows? And the 200 people that you didn't buy this thing, okay, which is probably everyone, maybe they did nothing towards working on their abs. Some do just because, and some don't. Okay. So just looking at and from an observational study, even if you notice a difference between the two groups, those who bought the product and those who didn't, that doesn't prove that there's some connection. We would have to do an actual experiment, okay? And in an experiment, we find volunteers, and then we give some of them this ab product, and some of them we don't, okay? We also try to control everything about these people's lives as much as we can. That's reasonable, okay? What we don't want is we don't want the people who have the ab product to be doing like an exercise regimen, while those who aren't who don't have the ab product to not be doing any exercise, okay? If people are going to do exercise, we want to make sure everybody across the board is doing the same amount of exercise, the same kind of exercise. We want to try to control their diets, okay? We want to make sure everything about these people are as similar as possible, with the one exception that these people have the ab product and are using it, and these people do not, okay? We want to try to make the two groups as similar as possible, so that at the end of the study, if we notice there is a difference between the groups, that difference can be attributed to the fact that one group had the product and the other group did not, okay? If at the end of the study you don't find a difference, then that would indicate to us that there's probably not a whole bunch of difference between the group that had the product and the group that didn't, okay? But again, that's taking into account that we're trying to control as much as we can about everything else, with the exception of the treatment variable. Does that make sense? Okay? And if you do that, and it turns out that those who use the ab product do actually have stronger abs than those who don't, then you can conclusively say somehow this product works, okay? So an experiment, it's conducted to see if changing something has an effect on something else, known as the treatment variable and the response variable, okay? We try to control all other variables that can affect the response. Okay. It's not always possible, okay, but we try it, okay? We try to control all other variables that can affect the response, so that everyone is as similar as possible. And if there's a difference between the two groups at the end, then that difference can be attributed to the treatment variable. So, in an experiment, we can make cause and effect conclusions. All right. In an observational study, not make conclusions. Oh, another important distinction is that in experiments, we assign the treatments. Okay, so let's see if you can tell if something is a is an experiment or if it's an observational study. Okay, so let's say there's some research going on, and this is how the research goes. We have we're observing. Let's say there's 40 athletes, and let's say, or maybe not athletes. Let's say bodybuilders. And so let's say some of them are using steroids, okay? And some are not. So and we go and we measure, I don't know, the size of their biceps or something. Okay. And at the end of the study, it turns out that those who are using steroids have bigger biceps than those who aren't using steroids. Okay. Is this I don't remember what words I said. Okay. But at the end of this yeah, is it an experiment or an observational study?
Observational.
Observational study. Why is it an observational study?
Because we're not controlling variables.
Yeah, because we did not assign treatments. We did not assign treatments there, okay? We did not say, tomorrow you're going to start taking steroids, okay? And tomorrow you are going to stop, or you're not allowed to touch anything that has whatever steroid stuff in it, okay? Okay, so we didn't assign those things, okay? So, it's not an experiment, okay? And at the end of the study, it turned out that those who use steroids have bigger biceps. From this study, does that mean we can say that steroid use is correlated to larger bicep muscles? So based on this study alone, the answer is no, okay? Because it's not an experiment, we cannot make cause and effect conclusions, okay? There could be all sorts of other things that could be going on that could cause larger bicep muscles or not, okay? Now, in our brains, we say, oh, people use steroids because they want bigger biceps, okay? That might be a reasonable conclusion to make based on all sorts of other things and possibly experiments that have been done, okay? But strictly from the sense of observational study and assigning treatments, we cannot make that kind of conclusion. Okay, so from an observational study, you cannot make a cause and effect conclusion. Okay. All right. Let's say we want to know if using Miracle-Gro helps your plants grow taller. Okay, so you maybe you get 20 potted plants. All right, whatever, some kind of thing, and to 10 of these you add Miracle-Gro, and to 10 of those you just use water. Okay. All right, what is this?
Experiment.
This is an experiment, right? Because I am choosing which plants get Miracle-Gro, which ones do not. Okay? They don't get to control that. The experimenter, gets to make that decision. Okay. All right. So at the end of the study, let's say the 10 plants that do get Miracle-Gro, let's say they do happen to be taller than those who didn't. What does this mean? Okay, so there's a few things we're going to learn about this more, but at this point, we might be able to say that Miracle-Gro actually causes the plants to grow taller. Okay, we're going to learn about the data analysis side. Okay, but you know, if the difference is dramatic, let's say. After a few weeks on water, the plants grew 2 inches, and after a few weeks with the Miracle-Gro, the Miracle-Gro plants grew 10 inches or something like that. And it's consistently 10 inches across the board in order to consistently 2 inches. From something like that, we can conclusively say it seems that the Miracle-Gro has made the difference. Okay, assuming that everything else about these plants was the same, that they all got the same amount of sunlight, that they all got the same amount of water, that their soil, everything else about them was the same, with the exception of the Miracle-Gro versus no Miracle-Gro. Okay, that would be an experiment. You can make a cause and effect conclusion. All right, are there questions on that? Okay. Okay, great. The book goes into it in a little bit more detail. It talks about with experiments you have things such as placebos and keeping the subjects blind. Okay, basically, when you do an experiment on people, you don't want them to know which treatment they're using, okay, or that they've received, okay? If you're going to give some people drugs and some people no drugs, you don't want the people to know that they got the actual drugs and they did not get the drugs, okay? Because the mind is a powerful thing and that can affect your outcomes. So you use things like placebos so that nobody knows whether they have the actual drug or the fake drugs, and that way you can compare your results versus the placebo, okay? Because it turns out whenever you use, if you give people a tablet and says this will make your headaches go away, even if it's not painkiller, most of the time people's headaches go away, okay? That's the placebo effect, and we still haven't fully understood everything, but we know that it does happen, so that's why things like that need to be counted. Okay, we're going to learn a little bit about visualizing data. Okay, this is the beginning of chapter 2. We're just going to get into a couple sections of chapter 2, and then we'll call it a day. All right, see you guys next week. Okay, so let's talk about visualizing data, and in particular we're going to deal with numeric data. Alright, so let's say let's say we go around the classroom and I interview or just survey 10 students, and I ask, how many children do you have? Okay, we'll have the student. Alright, so we got student, we have Adam and Bob and Kathy, etc., 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 etc. Okay? And we ask, how many children do you have? Alright. This is a numeric variable, right? Number of children somebody has, that's a numeric variable. It tells you how many children somebody has. Okay, and so let's say we go through and we have 0, 0, 1, and let's just say 3, 4. Okay, so let's say we go 0, 0, 1, 0, 2, 0, 0, 0, 1. I need one more. Another 0. Okay, that looks like an 8 now. This is a 0, and then another 0. Okay, so I got 10 students, and 1, 2, 3, 4, 5, 6, 7 have 0 kids, 2 have 1 kid, and 1 has 2 kids. Okay, that's the result of 10 students. Okay, well, so here, if we want to talk about an average, or the mean, what would we do? We would add up all of these numbers. And what number do I get when I add them all up? I get 4, and I divide by how many numbers we have. And I have 10 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the average number of children, at least for this sample, is 0.4. Okay, we can visualize this with a dot plot. Okay, so whenever you make a dot plot, and this applies for any situation where you're visualizing numeric data, okay, you start off by drawing a number line, okay? So I'm going to draw 0, 1, 2, 3, 4, etc., etc., okay? And so for a dot plot, I put a dot for each person at the number that they have, okay? So I put a dot for Adam at 0, a dot for Bob at 0, a dot for Kathy at 1, and then I just keep going down the line, okay? Do this. Something. Whatever, okay. And this is my dot plot. I have 7 dots here because there are 7 students that have 0 children. I got 2 dots because I've got 2 students with 1 child each, and I have 1 student with 2 children. 2 dots. They're a dot at 2. Okay. So how many dots total do I have? 10. I have 1 dot for each student. Is that okay? All right. Let's say I went to Alright, let's say I go to, I don't know, a factory, okay? And I survey 10 employees at this factory, and I ask each person, how many children do you have? Okay. What do you think the dot plot there would look like?
More grade.
Yeah.
There would probably be more like under 2 or 3.
Yeah, we're probably gonna have not as, so here, I've got a bunch of people at 0, and a few people at 1 and 2, and not very many more than that, okay? Now if I go to a factory, or just any workplace, really, okay? So someplace that's not a college, and I ask how many children do you have? I take a survey of 10 people, and I ask how many children do you have? Okay, if I make a dot plot, again, I start off with a number line, okay? And so maybe I got 10 people, and we got, you know, you know, maybe we get different people again. And maybe this person has 2 kids, and this person has 3 kids. This person has 3 kids. This person has 0. This person has 1. This person has 0, and this person has 2, and 2, and 5, and 1. Okay. Maybe this is the number of kids here. Okay. So the dot plot here, I'd put a dot at the 2, and the 3, and the 3. 0, 1, 0, 2, 2, 5, 1. Okay? This is the dot plot for number of kids, 10 people selected at a factory, okay? Is this okay? So this is the raw table of data, okay? This is number of kids, and this is person, and we get this. Alright. Which dot plot, or which graph, shows more variation in the number of kids? The factory, right? This one has more variation, okay? And what do we mean by more variation here?
Different numbers.
Yeah, it's not just that there's different numbers, okay? Or that we've got, here I've got 0, 1, 2, 3, and 5 represented, okay? Yeah, there's more spread here, okay? Over here, most people, almost all the people surveyed had just 0 kids, okay? And yeah, you might have people with 1, you might have people with 2, but most of them had 0, okay? At the factory, okay, so when you, you know, if I pick someone at random from the classroom, and I say, okay, so I got someone at random in the classroom, let's make a guess how many children this person has, you'd be pretty good if you just said 0, right? You'd be right most of the time if you just said 0. Okay. Over here, if we played that game, I said I picked a random person from the factory, and I said, how many kids do you think this person has?